All right, hi everybody. Here's an example of a real-life application problem that you're going to be similar to ones that you're going to have to do on your homework. So I thought I would do this one for you, so then that way you don't have to worry about the sub trying to explain it, and or one of those wonderfully boring videos that you get off the DVDs. So you are going to be designing one of those big industrial planters that you see out on the sidewalks and stuff at businesses. And so before we can design that, you need to know how big of a liner we can make. And you've got 6-foot by 15-foot pieces of sheet metal that we're going to turn into the liners. And we're going to do that by cutting out the corners of those so we can fold up the edges. And so what we need to do first of all is we need to see what volumes are possible first with the liners, and then from there we can design the boxes around them. So to do that, and I put this picture here just so that you can see what we're doing. You're welcome. All right, so write an equation of the function that represents the volume of the liner. So the first thing that we need to do is here I've kind of drawn out the liner. It's 15 feet wide, or 15 feet long, 6 feet wide. Now remember I said what we're going to do is we're going to cut out these notches here, and they're going to be the same size, and then what we're going to do is we're going to fold up the edges. That way we don't have leaking and all that other good stuff off the sides. So we've got each of these, we don't know how big that's going to be, so we're going to leave them to be x. And that's actually going to become the height of, because remember this is going to be folded up, so that's going to be like the height of the liner. So for our volume of this, length times width times height. Welcome back to geometry. So the height we know is going to be x. Now the question is, how long is this planter liner going to be, and how wide is this going to be? And so what comes up from there is this. The length here is 15 feet all the way across. Now remember, well, first of all, so what do you think the length is going to be of the new planter? Hopefully you said a number less than 15. Remember, we are essentially looking for this distance from here, to here. That's why you don't have your slate sideways, sorry. So it's going to be 15 minus what? I got to subtract this space right here, and I've got to subtract this volume right here, that length right there. So I'm taking away 2x's. So this length here is actually 15 minus 2x. And the same thing is going to be told true here from the width. I'm looking for this distance from here to here. I've got this is x, so I've got 6 feet minus 2x. So that's going to be your width. And then, as I said, the height is going to be x, because when this gets folded up, that's going to be how tall it is. So that's your volume function. Now the question here in part B, well, first of all, I do want to ask yourself this. What is the maximum height that this planter's liner is going to be? Keep that in the back of your head. We'll come back to that in a second. So what is the maximum volume possible for the liner? Now here's the question. How do I do that, Mr. Hayes? Good question. The way that you do this is this. Pull out your graphing calculators. And so you're going to go to your graphing calculator. And let me move this up so you can see it a little bit better. So we're going to clear that out, and we're going to type in that formula that we just came up with. You don't need to multiply it out. So we're going to type in 15 minus 2x times 6 minus 2x and then times x. Okay. Now when we graph this, go to zoom, and then you can hit number 6 standard, because that'll bring us back to the negative 10 to 10 set. And you're going to see this. Not incredibly helpful. Now remember, v of x is our volume, so we want to see what the highest that this is going to go. A couple of things now. Remember, I asked you what the biggest height you can have. That's your value of x. Hopefully, you said the biggest height that you could have is 3. Because remember, we have 2 of these, right? We have x over here and x over here. So as these get bigger, the side gets smaller. What eventually would happen is that this could go all the way up to here. You'd have an x here and you'd have an x here. So in other words, the highest that, that could eventually go to 0. If you were to solve that out, you get a value of x equals 3, which means that you would actually have no width of this thing at all. You'd have this big trough, and like a big V shape, and you would only have 2 heights of 3. So because of that, when we come back down to here, and we go back to our calculator, go to our window, we can't have negative heights. So I'm going to make this -1 just so we can frame it nicely. Our maximum height is 3, so I'm going to go ahead and say 4, just so we can frame it nicely. Our y minimum, you can have negative volume, so I'm going to make negative 1 so we can see our axis nicely. And now our maximum volume, I'm going to take a guess and we're going to just say 50. Okay, so now when you graph this, you're going to see the polynomial come up, and we're just a little short. Now this continues on over here, but we don't care because that's out of the range, or out of our domain. So we need to make this a little bit bigger, but the height of this graph is going to be the maximum volume that we can have. So I'm going to go back to window, go back down here to y max, and I'm going to make that, let's try 75. Hit graph. So again, it's going to come up, and there we go. This right here is your maximum volume. The question is, how do we find that? You can trace it. You can use your arrows. Best thing that you can do is you're going to go to zoom. You're going to go to calc, which is second, and this button here, and you're going to say number 4 maximum. And you're going to move to the left of the highest point, hit enter. You're going to go to the right of the highest point, and you're going to hit enter. And then you're going to hit enter again for your, and that says guess. So you're going to move up here to the middle, and you're going to hit enter. And it's going to give you that. Your maximum now is at x equals 1.3. So x has, okay, x equals 1.3 feet. 1.32 feet. Oops. And it has a volume, which is your y value, of 54.81. That's going to be cubic feet. Okay, so that's the maximum. So if we made the sides that. Now, of course, that's kind of awkward. So the next question that they could ask you is something like this. And again, you're going to use your calculator. If we need to make a liner that has a volume of 40 cubic feet, what 2 heights could we offer our customer? So you're going to go back to your calculator. Go back to y equals. And we're going to graph y equals 40. So now when we graph that, you can get the straight line across. And our 2 answers are going to be this intersection right here and this intersection right here. This way you can say you need 40 cubic feet of dirt to fill this thing. Makes it a little bit easier for people to plan. Because remember, people are lazy too, so it's your job to make their lives easier. So what you're going to do here is, again, you're going to go to this calc feature back here, and you're going to go second, calc. And instead of saying maximum, you're going to say intersect, so you're going to choose number 5. Now, I would recommend doing it this way. You're going to kick back here, get close to the intersection. It says first curve, you're going to hit enter. When it says second curve, notice it's marked the first curve, it's jumping down here to the straight line. You're going to hit enter. And then it says guess, so you're going to go over by the intersection, you're going to hit enter. So one of your answers is going to be for a volume of 40, you've got 0.6 inches. So for one of them, you've got x equals 0.606 feet. You can turn that into inches, etc. if you wanted to. And then back over here, we need to do the same thing over here at this volume. Because again, you know, let's face it, you could come up with different things. So you're going to go second, calc, intersect. So people also like variety. So I would, again, move over so you're close to that intersection. Okay. Whoa, too far. So you can hit enter for the first curve, enter for the second curve, and then enter for a guess. And this one also has one of 2.124 feet. So 2.124 feet. And then you can adjust it from that. Okay, so that should help you with the 2 questions up in the 90s for tomorrow's homework. Hopefully, if you need to and want to see this again, the sub will be nice enough to run that. And look at the examples in the book would be the other thing. So I will see you on Thursday. If you have any questions, call, text me, whatever tonight. Talk to you later.